Okay, I'm recording now. We're talking about the pedigrees for your sex-linked conditions. It's going to look the same in every way, except that you're going to see that only males are affected. And the person circled in red here is our client. The first thing you're going to do is go through and just identify the sex chromosome genotype. So, you know, XY, XX, etc. Now, here's where we have to make a distinction. And you're going to want to leave yourself a lot of space for this one. We actually have two different X chromosomes. You can differentiate these in a lot of different ways. One of the easiest ways to translate from doing the autosomal recessives is to make X big N and X little n. That means there is no plain X. Every single X, if you're doing this system, has to have either a big N or a little n. So in this case, this would be affected. This would be not affected. You know, what we might call normal, but I hate that word. So if we look at that, if we now go back and look at this guy, whoops, which X does he have? He has X little n y. Which X does his brother have? He also has X little n y. Which X does his dad have? X big N. Okay. What's his mom's actual genotype? Is mom affected by this condition? No. So we know she has one normal X chromosome, one X big N. But where did her sons get that? From her. So we know that she has to have one X little n. These are actually easier to do in terms of figuring out genotypes than the autosomal recessives, because there are really fewer options once you narrow it down by sex. Okay, what do we know about this mom here? Do we know about the two guys who we just looked at? Whoops. Do we know anything about their sister? Well, is she a carrier? Can we figure out the percentage chances that she's a carrier? We know she's not affected, so we know that she has at least one big N. What are the odds that her other N... Yes, sir. Yes, please do. I'm so sorry. What are the odds that her other X is the X little n? So, let's look at this. Where did she get the X big N from? If you're a girl, you got one X chromosome from yo papa. Where'd you get your other X from? Yo mama. So, knowing that she got the other X from her mother has two different X's that she could have passed on. What are the odds that she's a carrier without doing a Punnett square? How many of you can do this? There are two chances for her to pass on an X. Let's do a Punnett square for this. So if dad is, let me get a clean space here. If we know that dad is X big N Y, and we know that mom is X big N X little n, now we don't have, for figuring out the possible genotypes for the daughter, we don't even have to do this, because we know she didn't get a Y from her dad. We know that. So there's a 50% chance, oops, I gave it away. There's a 50% chance she got that little n from her mom. There's a 50% chance she got a normal n from her mom. So we don't know her genotype, except that we do if we look down a generation. We do if we look down a generation. How do we know her genotype when we look at her sons? So let's get rid of some of this. Well, okay. Who can tell me what her genotype is by looking at her sons? Bailey, what is it?
X little n.
Yeah, it's little n. How do you know she's got an X little n?
Because
Yeah, I guess it's her only son. I wasn't looking closely. What's his genotype? X little n, Y. Well, the only place he could have gotten that X little n is from his mother. So she has to have an X little n. Okay, does that tell us what our client's, this is our client, remember, does it tell us what our client's genotype is? Well, let's establish what we do know. We know that she has 2 X chromosomes, right? She's biologically female, she's XX. Is she affected? Nope. So we know she has at least one X big N. Do we know what her other X is? No. Can we know? No. Not without genetic testing. Now, could we know her sisters? How do we know her sisters? Because she has an affected son. You know, so if this is color blindness, if you have color blindness in your family, uncles and nephews, if your uncle is your mom's brother, you might just share something with him. Okay? And you know, we could trace this if this is color blindness, this trait from grandma to daughter to son, or to daughter and to great-grandson. You know, we can trace the path. What I expect you to do tomorrow, and I think at this point, you guys are pretty good at just doing plain pedigrees. Tomorrow, by the end of 5A, I want you to have the pedigree, and I'll list this on here. I want you to have the pedigrees for the sex-linked or X-linked done. Okay? Just building the pedigree. And like I said, you guys are pretty good at this point. You're getting really good at building pedigrees. Then I want you to have genotypes. We're going to be working together. So really, I would like it if you could get those pedigrees done as homework so that when you walk in here tomorrow, we can do genotype labeling together and that will get done by the end of 5A. But in order for that to happen, I want you to try to build the pedigrees on your own. So try to build those tonight. When you walk in tomorrow, I'll help you check them and make sure you're on track with them. The letter writing is something, we're still going to have some time to work on it this week, but the letter writing is something that I do expect you can do a little bit of that out of class. I will help you edit in class, but you shouldn't need class time to work on the letters. Okay, other questions about the genotypes and sex-linked? Yes?
Are we just doing the rough version, or are we actually doing the...
Well, get the rough version done. Once you've got a rough version done, I'll help you check it over. And you should do all of the genotype labeling on your rough version. Once you know you've got everything right, then you can start doing your final. But yeah, don't like bust your butt trying to get a final perfect copy tonight. But get your rough version of your pedigrees for sex-linked done, and then I can help you check them and make sure your genotypes are all good tomorrow. Okay? Other questions, comments, or concerns? Yes? No? Okay. You guys are doing a really good job. I'm seeing a lot of good stuff. So